Yeah, welcome to our group meeting today. Uh, yeah, I would start with asking you, does anybody of you have questions or comments or would like to tell us something or present something?
I can present my table of contents, like a broader one.
Yes. I make you co-host. Find you co-host. Yes, should work now.
Okay, I will share the screen. Okay, can you see it?
Yes.
Okay, so this is the backbone of the thesis, and I've added some comments under every subtitle so that it would make it clearer what it is about. So it starts with an introduction and the background. I was thinking about like introducing the recent related work on trustworthy AI in this part, but I think it's also possible to move it to the second chapter. I don't know. Well, motivation, it's about what motivates the why this thesis is done because of the company and the EU projects that are involved. And of course, some research questions and the structure of the thesis. And then like one of the main parts is the trustworthy AI. I'm defining it through the regulations of EU, USA, and OECD, like what are their requirements for AI to be trustworthy. And it also introduces the different principles that everyone has. And then in the 2.2, I will elaborate further the principles that were already introduced to just explain what exactly do they mean. And like a small chapter on ethical AI, like how ethics are considered in this discussion on trustworthy AI. And also a part on AI alignment, like the issues that may come up later when the AIs develop even further, so that we need to make sure that they do what they need to do, but they also, like, maybe in a sense, have this human way of thinking that they know when to stop and something is not achievable very easily, like very simple task. Let's say like getting a coffee. So if the coffee machine is broken, then the AI knows that it's fine, okay, whatever. It doesn't go further. Then the third chapter is about explainability, like introducing the concept of explainable AI and how it is related to the trustworthy AI. Then about explainable object detection, so how explainability has been researched in object detection problems, and then going through the different techniques that can increase explainability in object detection. And then the model that will be used is YOLO V8 to be precise. So I will introduce that model and how it works, what it has, and then talk about the explainability in the context of YOLO, like how it can be researched there. And there are some limitations with YOLO, like it doesn't detect small objects very well. So mention that sort of things. And then the experiments. First, I will introduce the methods, the model that was developed by someone else, and the methods that I will be using. So here I have like 3 different types of experiments. First is like assessing the model to see how well does it actually work. There are a lot of videos that I can use it on, and I was thinking of maybe like grouping the videos in some way, because there are, for example, some videos only have like this path, and then a machine will run through the path and then see how the model detects the objects and how confident it is in it, and whether the object is very close or farther away, that sort of things, and just like get some numerical values on it and how well it works. Yeah. The second is like tuning the parameters that YOLO has, these parameters that it works on, and they can be changed. So taking one video where it doesn't work like super well, it detects partially, but not all the time. So try to sort of improve its the way it works through this parameter tuning. And the third one is like occlusion attack, sort of like choosing some points that would seem reasonable and adding some sort of patches there and see how the model reacts to them. And then the final chapter is the conclusion.
Yes, very good. Thanks a lot. Are there any comments by the audience on this structure? So this is a table of contents draft for a master thesis.
Regarding the subtitle 5.1, the methods, I suppose this method is the background and literature review about these methods is involved in section 3. I mean, I cannot clearly see the relation between the methods and the other previous sections. Are they the is a background
Yes, so
introduced there?
yeah, in chapter 3 I will introduce like the different methods and techniques that can be used, and then in chapter 5 stating the methods that will be used in this experimentation. So yes, that sort of relation there is.
Okay, thank you.
Any other questions, comments? So maybe I then comment, or I could tell how I will then read your thesis. So this looks now very good. So you have really thought through, planned well the overall thesis. you now write the draft. At some point you submit, and then I will get the the request by a study coordinator or a master thesis coordinator to evaluate your thesis, to carefully assess your thesis. And in general, I only read the thesis in detail then. So I cannot promise the master students in my group or that I supervised any detailed review before that. But when I read them in detail, so some basic things, some like sanity checks that I always look through is first, in the introduction, do you clearly formulate the goal of your thesis? So what is the overall goal or ambition? What would you say here, Riley? Is it a review of the state of the art, a survey of the state of the art, or is it the application of a specific method to a specific data set?
I think it's more of a review of like the state of the art techniques.
Yes, that's perfectly fine. It's then important to be not too vague. So let's then add more details. State of the art techniques for what? So for explainable object detection in warehouse settings or something. So it's then good to go a bit more into to narrow it down. So this is also an aspect for the grading. How do you narrow down the objective or the research questions? Okay, so this would be one of the first things. The next thing, I'm a bit pedantic about the writing, the presentation. So I always want to have each section or chapter starting with an introduction. For example, I see here chapter 4, YOLO. So instead of directly then starting with section 4.1, I want to see or would like to see an introduction to chapter 4, YOLO, where you explain, where you guide the reader, which is me, at this point then mostly, how does chapter 4 build on the previous chapters? This is also related to the question of you, how do the different parts tie in together? So this I would like to have made as explicit as possible. Really, every chapter must start or should start with an introduction where you explain, in this chapter we now do this and this, in section 3.1 we do this, in section 3.2 do this. So you explain the contents of the chapter, but you also explain how this chapter builds on the previous chapters and how it serves the following chapters. So this should really, you should take me by my hand and guide me through the thesis when I read it. So these are basic things, the technical things. What else? When you, in the conclusion section, I would like then to see the closing of the thesis work. The closing in the sense that you then try to answer the research questions, or you explain how you conducted the review, or the results of the survey. So according to our numerical experiments, the methods for this or that are already quite good. So there's good. But in this or that scenario, the methods still need to be developed more. The state of the art is not there yet. Okay, yeah, one other sanity check that I'm very picky about. Every machine learning method that you try out in your experiments, for every method, I want to clearly see a definition of what are the data points. So are the data points snapshots? Are the data points moments of time or periods of time? For example, a 3-second time window. What are the features of a data point? What do you feed in the deep neural network, for example? Are these the pixel values of an image or something else like timestamps or side information in the form of text document? And what is it that you do with the output? So what do you want to predict? What do you want to predict? And the prediction could be a presence of an object, but the prediction could also be a good explanation for a machine learning method. So the explanation itself could also be viewed as a quantity of interest. Of course, there's design freedom, as I always say. It's up to you, but you must clearly formulate it. You must spell it out for me. What is the quantity of interest that comes out of the models that you want to predict? Beside this description, I want to see for each method that you try out a training error and a validation error. So how do you validate the models? A discussion of these two quantities. So, for example, explain why is the training error so much larger than the validation error? Then you could speculate this might hint at overfitting. So, but there's no need. I'm not so much interested that you try out or that you push the methods and the tuning as much as possible. So for me, it's rather uninteresting if you achieve a certain test set error and champion a Kaggle competition or machine learning competition. This is quite uninteresting for me when I evaluate your thesis. For me, it's more interesting how you document the work, so that you clearly state any training and validation errors, and that you briefly discuss them or compare them. And yeah, what I now told you is basically also listed in my GitHub page. Have you had a look at this master thesis info package on my GitHub?
Maybe, but I think it
Yes,
was
I
some
strongly
time ago.
recommend. I will send it out again on Slack and by email. This should be something that each master thesis worker should have a look at least once, because
Yes.
it's basically written down what I just said.
Okay.
Okay, yeah, thanks a lot. Do you have
Thank
any
you
other
very much.
questions? Yeah, something
Sorry,
else?
can I
Yes.
also add something? Could
Please.
you go up on the page again, please? So I was just wondering, I absolutely love that you're using trustworthy AI, but just as a side note, I'm wondering, why are you differentiating between trustworthy AI, ethical AI, and explainability in that way? Is there like a thought behind that, or is it just to introduce the different methods?
I think it just comes from the company that one of the main topics is the trustworthy AI, so it comes first, and like the ethical AI part is quite little. It's not very big, and then like sort of going deeper into one part of the trustworthy AI in the form of the explainable AI.
Yes, very good. That's what I just had in mind, and I also wanted to comment that in chapter 3, when you start, for example, the introduction, that you explain, as I understand, explainability is one aspect, one dimension of trustworthy AI, but there are also other dimensions of trustworthy AI. Yeah.
Yes.
By the way, does anyone know here the seven requirements, the 7 commandments of European Union for trustworthy AI? This is something each machine learning person should know by heart. So explainability is one, or transparency. What else do we want trustworthy AI to have?
Human in the loop?
A human in the loop. So we need a human in the loop. Yes. I think this is referred to as human oversight.
Yes, exactly.
Then we want robustness. So we want AI methods or machine learning methods that don't go crazy if one pixel is flipped of an onboard camera. Think about a machine learning method that controls your car, and for some reason one pixel is black in the onboard camera, and it now predicts 180-degree different direction while driving on a highway with 200 miles per hour. So we don't want such lack of robustness. So we want robustness. This is also a key requirement. Then also we want privacy preservation. And yeah, the rest you can look up. I also don't know it by heart yet, but I would like to know it by heart. So trustworthy AI includes explainability, but it's more than explainability. Okay. Any other questions or comments?
Just one thing. In the part, so in 2.1, just as a little side mark, be careful with using the word regulations when it comes to trustworthy AI, because there's no actual regulations. That is dependent on the fact that none of these are binding. So if you call them regulations, you're suggesting that they're legally binding, which is not the case. So just as a side note, be very careful with the wording of these things, because you might be suggesting something that's not actually the case.
Yeah, that's a good point. Thank you.
Yeah, it might be great if Diana, if you have time, that you could maybe review a draft, a first complete draft, at least of this chapter 2, and help Riley with giving feedback.
Yes, of course, I love that.
Yeah. By the way, what now, Diana? Yeah. For those who didn't know Diana before, we have some guests today. Also, Diana is an expert on AI law, and so is regulation a law? Is regulation a special case of a law? What's the difference between regulation and law? If you could comment a bit on this, Diana.
Okay, so regulation directive and directives, for example, are words that we're using in the EU context, and the regulation is binding law. It's basically EU law. But there are differences in what we have. So, for example, the guidelines on trustworthy AI that we have in trustworthiness are merely guidelines, which they are not legally binding. Regulations are directly legally binding. Then, for example, the GDPR is a directive. We also have directives, and directives are basically also law, but there is a difference in implementation. So when we're looking into national law, we have different models on how we implement EU law. So basically the EU comes and gives a law, and then depending on the type of law that the EU gives, it is included into national law. When you have a regulation, that is directly, so directly everything that is said is binding. When you have a directive, you have a lot of, the national states have some implementing act. So basically the directive says ABC, and then the national states can have a little bit of wiggle room on how they interpret ABC, and then they include it into their national laws. So these are like different types of law, basically.
Okay, thanks a lot for the clarification. Are there any other comments or questions? If not, then thanks again, Riley.
Thank you very much.
And yeah, let me welcome some guests today. We have some new affiliates. As you might know, I allow anybody to register as affiliates, so they will get invitations to this group meeting.
Yes, hello, thank you. Yeah, thank you for the invitation. I'm actually, well, not a coder, if you say so. So I'm doing a doctoral thesis at in industrial engineering and management, where my topic is the impact of AI on innovation, and I use the context then of pharmaceutical R&D. And what I am doing there is that I try to do a meta-analysis, then actually quantifying the impact, well then like based on a scientific research. And that's why I joined or asked to join this group. So I would like to consult then once I'm at that stage to see that I'm not like evaluating the performance of AI, I mean, wrong. And also then the first paper is actually a systematic review where I build a multi-level agent-based model of the different entities. Then I call them entities, these scientific papers that are applying AI within this R&D, pharmaceutical R&D context. So there too, I would highly then appreciate your feedback on that.
Yeah,
I mean, I have seen papers where they select the best AI model with the highest root square mean error.
Okay, okay.
Things like that. So
yeah,
it makes me feel a little bit unsure because my major is not mathematics, neither computing.
Yeah, if you have a specific paper that you would like to share or ask about, it would be very welcome to present here in one of these group meetings.
Yeah, absolutely. But could you, not today perhaps, because I took the paper up again after a small break, and I actually then produced a third paper where I focus on integration of the AI and pharmaceutical R&D, a human-centric exploration. So I'm building a little bit new here. So let me work on it a little bit so I don't show you.
No worries.
Yeah,
no worries.
Thank you.
Welcome.
Thank you.
Welcome, Makita. Okay, then we have Homer. You.
May I ask a question?
Yes, please.
Not being an expert then in this kind of stuff, is it true that machine learning is not AI? well, machine learning is not equivalent to artificial intelligence based on Russell's book, Norvig and Russell's book.
No, yeah. Yeah, so I like to be I find it always difficult to talk about this word meaning of these buzzwords. So, but it's important to follow the discussion. So for me, machine learning is anything, any computational method that fits a curve to data points. So when you can reasonably interpret the method or the application as this curve fitting problem or a method for curve fitting, then I would call it machine learning. If you do something different, like there is logic, formal logic, there are like expert systems that just follow strict logic rules for deriving theorems from axioms, then this I would not call machine learning, but it's still useful to provide insights. So this is what then the kind of the difference between machine learning and AI. So I would call machine learning anything that fits a curve to data points, and this is a small subset of AI. So AI is a larger domain, and a subset is machine learning. Although in practice, I would say when you look at the methods that are branded or sold as AI, then I would say 99.9999% this is machine learning actually. So there is hardly much now beside this curve fitting approach, and this is actually the philosophy of deep learning. The philosophy of deep learning is formulate whatever application you have as data points, which have a lot of features. Like a data point could be a molecule or a chemical substance, and take whatever you can measure about that substance, whatever you can measure in a lab with reasonable costs, and feed it into a deep neural network. And this deep neural network implements such a curve. And the output of this network, so the function value, is some quantity of interest, is the prediction for your label, which could be, this is good, this substance is good for a medicine, for healing or curing a certain disease.
Yep.
So this philosophy of curve fitting is basically what most of us talk about now when they talk about AI methods. This is a curve fitting method. So this is the established field of machine learning studies these curve fitting methods. So machine learning is everything that does this curve fitting, and whatever you do with data that is not curve fitting might be AI.
Yeah. I mean, I have seen sources saying then that stating then that machine learning is a part of AI is actually lowering what we mean with AI, because AI perceiving and censoring too, and then using logic and etc. to come up with something more than fitting these data points.
Yeah.
Do you agree with that?
So
McCarthy is the source.
Could you repeat again? AI is more than machine learning?
Yeah, stating that machine learning is a part of AI dramatically lowers what John McCarthy meant with AI. In essence, an AI agent perceives the environment by means of sensors and acts upon the environment through actuators, etc. There is logic, reasoning, decision making, and that makes the agents act autonomously, correcting itself with no human intervention.
Yes.
I mean, this is
I could agree with that. Okay, I could agree that, although I'm quite enthusiastic about then always destroying such conceptual principles, because without human intervention, this would mean anything where you at least need to change a battery once in a while cannot be AI, because you have a human intervention. Somebody is putting in a battery. So I'm not,
okay.
I like, also whenever I talk with people, they always are eager and passionate about coming up with cool definitions of machine learning or the difference between machine learning and AI. And then I always ask, why do you need this definition?
I need correct definitions, because I'm afraid that I am not collecting all the data because well, for the meta-analysis, I actually need to enter keywords. So that is my
Okay. Yeah. But what might in these questions, and I also sometimes I'm also interested in better understanding these definitions. And what I do now find somewhat useful is ChatGPT. So did you ask ChatGPT these questions?
No, I have been asking him question or her or it or whatever you call it. I'm working with him or it. Really, it's really nice.
Her.
I have the 4 Pro version and start to become productive.
Yeah. Oh.
Thank you.
Yeah, sure. You're welcome. So there's a chat. Okay. Yeah, here. So then, yeah, is there anybody else wanting to comment? Tell something about machine learning? I would then maybe ask Yasmin, now that we have also Yasmin, would you like to introduce your planned research topic?
Hi, everyone, and good morning. I'm Yasmin. I'm currently working in applications of reinforcement learning in electrical machine design and also on network federated learning.
Yes. So in her master thesis, Yasmin looked at machine learning methods that output the best configuration of engines, if I remember correctly.
Yeah.
So what would have been data point in this application? So if we model this as a machine learning problem, what would have been a data point? So a data point would have been some user requirement for an engine.
Yes.
So
And
a user
also-
requirement, yeah, could be, for example, I have a hut and I need a water pump, and this pump needs some engine. So I have the restrictions that I only have a solar power panel with that power. I only have a battery in my hut with that capacity, and I want to use the water every 2 weeks because I'm spending there a weekend. So these are all requirements from the user. And this is one data point. And what Yasmin looked at is machine learning methods that output a construction plan or an assembly or configuration of the best engine for your needs. Did I understand this correctly?
Yes.
Yeah. And to learn, so per se, this is a hypothesis. So machine learning is all about learning a function, very complicated functions though, that read in these user requirements and output the best construction plan for the machine. And to learn this function, she used a specific type of machine learning method, which is called reinforcement learning. Why did Yasmin use this type of machine learning method? Well, to learn the best hypothesis, we would need some training data in the most direct approach. So we would try out this hypothesis. So we feed in some user requirements to the method and we get out a construction plan for the engine. And then we could, if we have at our disposal, somebody tells us what is the correct construction plan. So there's some guru from ABB, this company, that was using this method, for example, and telling this is a good construction plan or this is a bad construction plan. So we would have labels, a supervisor. And then based on this feedback, we would either change the hypothesis a bit or leave it. However, what happens if you don't have such an expert? If you don't have such an expert, how do you know if the construction plan was good? How can we get a feedback signal that tells us the construction plan that was spit out by this machine learning method was good? Well, we might use some indirect feedback. We could build the machine using the construction plan and then measure it. And then measure, does it satisfy all the requirements? How much energy does it take? Does it break? How long does it last? And then we get some feedback. But this is an indirect feedback, which we call in machine learning a reward. So a reward is an indirect supervision, an indirect teacher feedback signal. And whenever you have only such rewards, you could use methods called reinforcement learning. Reinforcement learning methods, they don't need that somebody tells you what would have been the correct construction plan. But these reinforcement learning methods, they only need some feedback. So it was rather good, was not so good, was very bad. This kind of reward you can feed into a reinforcement learning method. Did I somehow correctly explain your approach, Yasmin, or would you like to add something?
No, it was totally correct.
Yes, and how did you apply reinforcement learning methods? Did you have to design or implement reinforcement methods from scratch, or was there some library you could use?
No, I used the proximal policy optimization method as a reinforcement learning method, but the most challenging part was designing the reward function.
Yes, so the hard part was here to choose or design the reward, the indirect feedback. Once you have it, once you know how to measure the construction plan, how good it was, you can feed it into some ready-made library, a method that is provided by a ready-made library in Python or your favorite programming language. So the hard part is not the coding or running the machine learning algorithm. The hard part is these design choices. What do you use as reward? What do you use as data point? Is it a user requirement or is it something else? Some kind of sustainability requirements. So you cannot produce anything that produces more CO2 than some level or something like this. So this modeling the application, formulating it as data points, as features, as labels, and what you use as loss function or reward, this is the hard part. And this is where most of the brain power will go in your master thesis work and in any applied machine learning work. Okay, that was about machine learning for engine design that Yasmin is now working on and will work in her PhD. Okay, yeah. Anybody else passionate or eager to share a machine learning story, machine learning problems, machine learning papers or methods?
Hi, I can share something.
Yes.
Yeah. My name is Xu Yang, and I'm also a PhD student in Alex Group. And since we are talking about reinforcement learning, and so the topic I'm interested in is also involved in this topic. Can I share my screen?
Yes. Give me a second to make you co-host.
Okay.
Yes, should work now.
Okay. Okay. I didn't prepare a presentation or slides for this talk, so I gave it briefly. And here's the picture. The problem I'm interested in is vehicle routing problem. Simply is here's a depot, and we have a vehicle or multiple vehicles, and we go to each node or each customer, and we deliver stuff. And when the capacity, when the item's capacity is reach our vehicle's capacity, we go back to the depot, and then we deliver more stuff until we visit every customer, and the like the total roads is end. So we call this every circle is a road, and the whole road to this problem is one solution. Our goal for this problem is to find the minimized solution, which means minimize the traveling length to this whole problem. So now the methods I'm working on is model this problem as a sequence-to-sequence model. Sequence-to-sequence model is usually used in natural language processing, because when you use ChatGPT or when you translate English to Chinese, you are actually input a sequence of words and output a sequence of words. Usually the input and output, the length of the input and output are different. So in this problem, we can model this problem into a sequence-to-sequence model, because we are actually input a sequence of nodes with all their information, and output a sequence of nodes in order. So in order to do this, now all the work are based on a model called point network, which is you input all the nodes and with some changes to the attention model within the big model. And we can actually like output the nodes depend on the input, the number of the inputs. So for example, the model now can, when you deal with 20 nodes and 50 nodes and 100 nodes, actually you can only use one set of hyperparameters to deal with all kinds of problems. This all the nodes can do. So this is how the problem are modeled. And in order to derive the parameters, we use reinforcement learning to optimize it. So imagine you're a vehicle at this point and you want to go to the next point. So you sample it from this point to other points. And from here, you can use reinforcement learning to choose what's my next action and then to go to the next point. So this is basically the method I'm focusing on to deal with. But actually, this kind of problem has a lot of other. This kind of problem has a lot of other methods to deal with, not just sequence-to-sequence model and reinforcement learning. You can actually use other traditional heuristics to deal with, or you can use a deep neural network to model it and use other methods to train to optimize it. Yeah. Anyone has any problem or question?
Thanks a lot. Are there any questions? So this reminds me also, this would be useful now. Yesterday I was shopping in my grocery store, but still I have not the location of all the products in my backhead. So this would also be handy, such an app for optimizing my path through the S market or K market or whatever shop you want to use. So I minimized my shopping time.
Yes.
The stops, so the nodes here would be the the products or the shelves where I can find the products.
Yes.
So this
yes.
might be interesting for optimized shopping experience. At least for me, one criterion for optimized shopping experience is that the duration is minimum. Okay. So do they also in this paper report numerical experiments results?
This paper?
Yes.
Yes. Here, this paper actually have a pretty good result compared to even the state-of-art method. So
what I always like to check is sanity check when I read a machine learning literature. Do they also come up with a baseline? So it's of course always nice to compare with state of the art, although it's often subjective. What is state of the art? So you try to find 3 or 4 other methods which you can outperform on your data set, and then you report it in the paper. But do you know about a way to come up with a fundamental limit? So a lower bound for these numbers, or don't know, should the numbers be low or high? So some bound for these numbers that no method can beat.
I think no method can beat. I think a lot of methods are compared to this heuristic generally. Yeah, because this area is kind of new, so new algorithms are coming out every day. And since we are speaking of the results, actually I have do have a question want to share. So if anybody, so I'm focusing on this paper, but I also read another paper about this question. They use a different model and different method to train, and their result mentioned the paper I'm working on. So this is just what I have read yesterday, and result chapter 4. Here it mentioned this paper I just talked about, or yeah, and here the training time is 4,000 hours. So I was kind of shocked by the time. Or so here it says the running time of here is estimated from the paper. So yeah, I can't explain this yet because I haven't really like tried to. I haven't had time to try to find the reason behind this. So yeah, I'm just point it out here.
So regarding computational complexity, this seems to be not competitive.
Yeah.
But what about the performance? What do they state? What are the numbers in this table?
The numbers are pretty good. Actually, it's the best one about vehicle routing problem.
What is the meaning? How is the cost defined here?
Here the cost is the length, the traveling distance. Here.
Mm-hmm.
Yeah.
So it evaluates the quality of the final route that has been found in the end.
Yes.
Well, it depends. If you have enough time, then you can run it. But if you should adapt, so I mean, a first task could here be to try to decompose these methods in this curve fitting picture that I have shown before. So what would be a data point? What is the input to the model? Is the input a specification of the distribution network of the nodes, and you want the perfect route at the output, or is the input the current state while you're on a route? So you want to learn in real time what should be the next move.
In this paper, you are learning it. It also a little bit changed from what I said just now, because it gives a solution. It gives an initial solution from a heuristic, and then it uses reinforcement learning on the route to actually change every node. And for example, it evaluate when it's this node, you're about to, this is already a good solution, and you choose one node, you choose how to change the route.
Mm-hmm.
Yeah, and yeah. Yeah, but maybe it takes more time to check.
Yeah. Yeah, maybe you could try now as an exercise to find out or to formulate this method as a curve fitting problem.
Okay, curve fitting problem. What do you mean by curve fitting? You mean perfectly fit the training data?
So what is it when you look at the training algorithm? What is it that you feed into this deep neural network? I guess they use a deep neural network somewhere.
Yes, they do. And actually is the it's a graph, it's the information about a graph. Here's the graph, and you feed into all the nodes with the coordinates, with their coordinates and their capacities. or
Mhm.
demands. Yeah.
Mhm. So the input is a current route plan and it outputs an improved route.
Yes.
I see. Huh, that's interesting approach. So it just learns a map that whose function is to predict an improvement.
Yes.
And this operator, what is shown here as operator, is a trained deep neural network.
Yes. The operator, I think it means the in the reinforcement learning, the how to say it? Like where you are. Or the operator can be the action you choose.
And so how do they train this operator? They show a lot of pairs of original route and improved route, so they know what was the right improvement.
Yes, they have a huge action space. Not huge, but around 20 something actions. And if they choose one, like they evaluate all the actions and they choose the action with the like a highest probability. And the reward here is when you choose an action and you actually mini or you let the traveling distance become less, then the reward is +1. And otherwise is -1.
I see. That reminds me of the setting that Yasmin had. So do they also use a policy, a proximal policy algorithm for optimizing, for adapting the operator based on the reward?
Yes, use the reinforce with a baseline.
Mhm.
Yeah. Your policy network. Yeah.
Reinforcement learning algorithm.
Yes.
Yeah.
And it's still combined with the sequence to sequence model.
Mm-hmm.
Yeah.
Okay. Yeah, thanks for pointing out this paper. Are there any comments or questions? Does anybody else have a similar application to optimize the route or optimize routings? Okay, if not, then thanks everybody for joining the meeting today and see you next week, same time, same place. Bye.
Thank you. Bye-bye.